Hello friends, welcome to Incredible Physics.
Hello guys, today we have to discuss how the spring constant of a spring change when it is cut into multiple parts. As we can see, we have a spring of length L and a spring constant K, and if we cut it into two parts where one part has length L1 and its constant is K1. So we should keep it in mind that for any of the spring, length multiplied with its spring constant is always a constant. If length reduces, spring constant is increased by the same factor, or we can say that L into K is L1 into K1. If we say that length L1 is half of length of the spring, then we can say that K1 becomes 2 times of K. Now we have to discuss about the combinations of the multiple springs. There are two types of combinations, series combination and parallel combination. So guys, we are going to discuss first about the series combination. As in the diagram, we can see we have three springs connected with each other. First spring is K1 constant spring, and second one has a spring constant K2. Third spring has a constant K3. We have to find the equivalent constant of the combination, which is assumed as K. So in series combination, we can see that we have connected a block as well at the end of the combination. Suppose due to the force of gravitation on the block, the first spring is elongated by y1 displacement in downward direction, second spring is displaced by y2, and third spring is displaced by y3, and the equivalent spring is displaced by the displacement y if the same force is applied on it. This spring is called equivalent if the same force is applied and it provides the same elongation as that provided by the combination. So we can see that spring 1 is experiencing a force K1y1. This is K1y1, and spring 2 is experiencing a force K2y2, and spring 3 is experiencing a force K3y3. Because all these springs are light, so they experiences the same force, or we can say that K1y1 equals K2y2 equals K3y3, and this is equals to mg, where we can find the values of y1, y2, y3. y1 is equals to mg over K1, y2 equals mg over K2, and by y3 equals mg over K3. On the other hand side, for the equivalent, we can say that if net elongation is y, then ky can be written equals to mg, or we can say y equals mg over k, because y is equals to y1 plus y2 plus y3. So after placing the values, we can say this is mg over k, and this will equals to mg over k1 plus mg over k2 plus mg over k3. So we have the formula of equivalent spring constant as 1 over k equals 1 over k1 plus 1 over k2 plus 1 over k3. So this is the formula to find the equivalent spring constant for this combination where springs are connected in series combination. Now, if we discuss the parallel combination of these three springs, where you can see in the diagram, we have three springs having constants K1, K2 and K3, and we have connected a block of mass m at the end of these blocks. This type of combination of springs is known as parallel combination, and we have shown one single spring as well. This is called the equivalent spring, and this constant K will be called the equivalent spring constants of K1, K2 and K3. Now we have to find the formula of value of K in terms of K1, K2 and K3. We can see in the diagram that this block M is experiencing a weight downward force mg, and Suppose the elongation in each spring is y in downward direction. So first spring is applied force K1y, second spring is applying force K2y, and third one spring is applying force K3y on the block in upward direction. Because block is in equilibrium, so we can say net force is 0, or we can say that K1y plus K2y plus K3y equals mg. For the equivalent spring, we can say that it has the same elongation in the spring as y, it has the same force due to the gravity mg. Then we can say that force ky is being balanced by mg. So for these two equations, we can say that right hand sides are equal, so we can compare the left hand sides as well. So we can say that ky equals k1y plus k2y plus k3y, or simply we can say k equals k1 plus k2 plus k3. This is the formula to find the equivalent spring constant if the springs are connected in parallel combination. Now we have to discuss a numerical. In this numerical, we have a spring of a spring constant K, and we have split it in 4 equal parts. As we have already discussed, if K was the original spring constant, then the individual part has 4 times of the original spring constant here. So in the right hand side, we have to find equivalent spring constant of the given diagram, where we can see 3 parts are connected in parallel combination, and after that one spring is connected in series combination with this combination. So first of all, we have to solve the spring constant of this parallel combination. This is 4k, this is 4k, and this is as well 4k. It has also the spring constant 4k. So first of all, we have to solve this combination. So in parallel combination, suppose the spring constant is k dash, so the k dash will equals to 4k plus 4k plus 4k, so it is 12k. Now this 12k is in series combination with 4k, and we assume that the net spring constant is k net, so we have to apply the formula of equivalent spring constant in series combination. So it is 1 over k net equals 1 over 4k plus 1 by 12k. After simplifying, it is 4 over 12k, or we can say it is 1 upon 3k. Hence k net equals 3 times of k. So guys, I think this concept is very much clear to you. If you like this video, please subscribe the channel and share the video. If you have any doubt or you want video on any another topic, please comment me. Thank you.